Bonjour, welcome to Wahsa Citizens Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slate. If you would like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 2 till 3 in the afternoon. And we are in our 5th week of our 9-week course. At this point, as we are halfway through now, you should be considering what work to submit for marking and actually submitting some. So a reminder that the support questions, the ones with the pencil icons, are not for marking. They are practice problems and you can decide which ones and how many to do. Totally great to do all of them. But if you're understanding a concept and you're feeling really comfortable, it's totally fine to skip questions. If you need more practice and what's in the booklet is not enough, let me know and I can send you more practice. The answers are in the back of your booklet, so please check your work to make sure you're on the right track. The key questions, the ones with the little key icon, are the ones to submit for marking. So please do all of these questions, showing all of your work, your steps, and your thinking. This way I can understand what it is that you understand, and it gives me more information if you're struggling with something so I can actually help you. So how do you actually submit your work for marking? Well, there's 3 methods. The first is to scan your work and send it electronically. You can scan your completed work using an app. If you have an Apple device, you can use the Notes app. And if you have an Android device, you can use the Google Drive app. Both these apps are free and generally come with these devices. If you're not sure how to do it, my YouTube channel has some tech tutorials on it and they walk you through how to use both of these apps. They're fairly straightforward to use. Then you can send it to me either through email at studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca. Or you could also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. Then the third method is to hand your work into your DEC. Then your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to fax in their work if that's something that's useful for you. If you'd like to connect with me through social media, both my YouTube and my Facebook are under the name B. Slate Wahsa. So you can friend me on Facebook or subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our videos. All of our radio Zoom classes are recorded, and I upload them shortly after airing onto YouTube and share them on Facebook. Also on my YouTube channel, there are short videos that explain common errors or confusing concepts. So that's a good place to go if you're struggling with something. There might be something there that can help you out. Math is an incredibly visual subject, so I strongly encourage you to tap into the videos to get the full experience, either joining me live through Zoom, though you do not have to talk to me, you can just watch, that is totally fine, or watching the replays on YouTube. This way you get the full experience and you really are setting yourself up for success. If you don't have access to the reliable internet and these are not options, let me know and I'm happy to send you a copy of the recordings so that you get the full experience. If you have any questions or concerns, please reach out and connect with me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is B. Slate Wahsa. Call me at the office at 807-737-1488, extension 2209, or also toll free at 1-800-667-3703. My office hours are Monday through Friday at 9 a.m. to 3 p.m., though I teach the last hour of my day, so that is not a good time to get a hold of me. All right, we are into a new unit today. We are starting unit 3. So we have covered half of material and we are diving into the next unit, which is a pretty big change of pace. So lesson 11 looks at trigonometric ratios. We'll be doing lesson 11 in 2 parts. Our learning goals are that at the end of this lesson, you'll be able to recognize and label parts of a right triangle, and you'll understand how to use trigonometric ratios to find unknown sides and interior angles of right triangles. You know that you've met the learning goals because you could identify the opposite and adjacent sides as well as the hypotenuse side. And you can solve for unknown sides using trig ratios, and you can solve for unknown angles using trig ratios. We will be doing sides today, focusing on that. And then in our next lesson, we will be looking at the unknown angles. All right, so when we'll use this in real life? Well, we're strengthening our comfort with numbers. Trigonometry is something that does pop up in people's lives in different ways, in terms of construction, surveying, carpentry, architecture, engineering. These are places where it does really show up, but many of us are not going to be in those fields. However, being comfortable with numbers is something that, because numbers are going to show up in our lives everywhere. So being able to apply numbers and manipulate them is really important. So that's part of what we're strengthening in our class. But let's first activate our brain with some mental math. I don't believe in Mad Math minutes. They do not support students or set them up for success in my experience. Instead, I like to work on strategies that help students to learn and make connections that are comfortable for them. Our question today is 137 plus 65, and we'll be using the strategy of adding up in chunks. So what this means, I like to do this on a number line, just how I like to organize my information, even if I was just doing this visually. So I'm going to start at one of our numbers, and it doesn't matter which one you want to start at. I'm going to start at 137, but you could start with 65 and then add 137 to it. And I'm going to add up in friendly groups of numbers that doesn't have to be the same numbers. They're just going to be a chunk. So I'm going to first add 30. Why am I adding 30? No, I'm going to first add 3. So 1 to get to 140. And then I'm going to add 2 to get to 142. So that is my 5. And now I need to add 60 as well. So I could add up in 10s or 20s. So why don't we do that? So I don't add 20s. So 142 plus 20 is 162, plus another 20 is 182, plus another 20 is 202. And those 3 20s is 60. So 137 plus 65 is equal to 202. And adding up those friendly chunks makes it easier to get there. All right, mine's on. What do we need to know diving into this new unit? So we need to make sure that we're comfortable with triangles to a certain degree. First, I want to remind you that our right angle is equal to 90 degrees, and this is the symbol, this little square in the right angle corner that shows that that angle is 90 degrees. So we don't write 90 degrees, we just write this little square in the corner that indicates that that angle is 90 degrees. The other thing to remember is that if there is no right angle symbol, even if it looks like it could be a right angle, it is not a right angle. It has to have the symbol. So even if the way that the drawing is, it looks like it could be 90 degrees, it's not there. It is not 90 degrees. 89 degrees and 91 degrees look really, really close to 90 degrees. And also drawings are not exact, and I generally don't measure my angles on my computer. I try to get something that is a ballpark idea, but the labels are really important, so pay attention to that. No indicator means it's not right angle. So then also we need to remember a little bit about how proportions and ratios work. So being in proportion means that two ratios or fractions are of equal value. So this is commonly, a ratio is the comparison of two values of the same kind. So a part-part ratio compares a number of parts of a whole to other parts in the whole. You can also have a part-whole ratio, compares the number of parts of a whole to the total of all parts in the whole. And a ratio may have more than two terms. So this all can be a little bit confusing just in terms of understanding this language, but we'll be using ratios, and so hopefully it will make sense as we move forward. So here, this would be a proportion 1/2, or 1/2 is equal to x over 50. So these are two ratios, 1:2 and x to 50 are two ratios. And the proportion is saying that these two ratios are equal, so that they are the same, though they might be different amounts of something, they have the same proportion, they have the same ratio in comparison. So the same here, 1/3 is equal to 65 over y. Again, these proportions are equal. So this is, so like the first one is saying one, for every one thing you have two. So if you multiply that, if you increase that by a factor up, so if we have 50 things, then we need to have 25 to 50 is the same ratio. So x would be equal to 25. Here, when we have a ratio of 1:3 is equal to 65 over y, this is saying for every one thing, we have three things of something else. So that means 65 is equal, or 65 to, how we can figure that out, we can use our Desmos calculator. So 65 to 3 times 3 is 195. So y would equal to 195 in order to have the same ratio, the same proportion. And here, where we have 4/5 is equal to a over 25 is equal to 32 over b. These are just all are equal. So this is saying 4 to 5 is equal to a to 25. So to get from 5 to 25, we multiply by 5. So to get from 4 to a, we have to also multiply by 5. So a has to equal to 20. So that 20 to 25 is the same ratio as 4 to 5. That's true. And the same way here, we can ignore this middle ratio, and it still says the same thing, that 4 over 5 is equal to 32 over b. So to get from 4 to 32, we have to multiply by 8. So to get from 5 to b, we also have to multiply by 8, which means that b is equal to 40 to have the same ratio, that 32 to 40 is the same ratio as 4 is to 5. Okay, so let's explore some new concepts and look at trigonometry. So as I said before, trigonometry is everywhere around us. Here, someone's surveying, and that their machine used trigonometry to measure things. Some other things that I didn't mention, blood stain patterns. So forensic scientists and forensic investigators can use that information of where blood is splattered, and using trigonometry are able to figure out information about crime scenes. I don't understand it all, but I know that it happens. Video game designers use trigonometry to code and to write video games, and then also you can even use it to play video games. You might not do all of the calculations, you may or you may not, but here is an image of Angry Birds where you can see that in order to take the shot, paying attention to the math of it is actually could help you make a better shot. And then also in space, astronauts and the engineers who send satellites and things up into space, part of that information in terms of what they want to measure, what they want to inspect, observe, all of that has trigonometry, can be parts of it as well. So trigonometry really shows up in various places. So trigonometry, in case you don't remember it from before, or you haven't heard about it before, is about the ratios of any two sides of a right angle triangle in terms of the reference angle. So sine, cosine, and tangent are ratios that can be used to find unknown sides and angles. So that can be really useful for scaling an object, which is something that we generally do using technology more and more. So here is the Wahsa logo, and by making it something bigger, I'm increasing my ratio, but you can see that my information didn't get skewed. It didn't get squashed in any direction. It just looks like I've just zoomed in. I'm closer to my information, and that is the same ratio, right? Even from the image that I had before, it looks the same. It's just that I'm closer. Or if I scale down, we can see still my logo looks the same. It is just smaller, so I'm farther away, but nothing has skewed because the ratios are the same. So thinking about it in terms of scaling an object can be really helpful when you are thinking about trigonometry and triangles. So a similar triangle is the same idea, is that we are looking at information about our triangles if they are different sizes. So here I have a triangle that has 3 angles and 3 sides. And here I have another triangle that has 3 angles and 3 sides. And you can see that my angles are the same. I have this top angle is 58 degrees, this top angle is 58 degrees, this bottom angle is 32 degrees, this bottom angle is 32 degrees, and these are both right angles. So our triangles look the same. They are just, one is bigger than the other, but their proportions are the same. And here again, if I have a larger triangle, my angles are still the same as my other 2 smaller triangles, but my side lengths are longer, but all of my side lengths are longer by the same amount. Nothing got skewed, nothing is squished. It looks the same, it's just a bigger triangle. So what that means is that our ratios are the same. So the ratio of A to B is equal to the ratio of X to Y, which is equal to the ratio of R to S. These are various sides of my triangles, and they're around the same angle of 58 in each of my triangles. So those ratios, if I were scaling it, are going to be the same, which could also be written as A over B is equal to X over Y, which is equal to R over S. These ratios, again, these fractions, you could think of them, are all going to be the same. Then if we were to look at a different comparison of 2 different sides, we can see that B to C is equal to Y to Z, which is equal to S to T. So comparing these two sides, their comparison is the same. And C to A, Z to X, and T to R, those comparison of those sides pairs are the same, which we can also write as a fraction. So then those are the pieces of information that we have, is that those three sets are all equal to each other. So within trigonometry, because those three sets of ratios are always equal to each other, we have come up with some language and some rules about those things that we can apply constantly. So first, we're going to look at the sine ratio. And this is on page 2 of your IL booklet in unit 3. So taking right angle triangles, the hypotenuse is always the longest side, which is across from the right angle. So this is language you need to know. And we're going to go over it over and over again because it's essential for you to know this in order to be able to set yourself up for success for these trigonometric ratio lessons. So the hypotenuse, you always find across from your right angle. It doesn't matter the orientation of your triangle. It can look in any direction, but you find your right angle, and the line that is the side that is across from that is your hypotenuse. And I label that HYP for hypotenuse. That's how I do it. You don't have to do the same as me, but that's how I do it. The reference angle is the important angle in the situation. So, however, if you're just having triangles, or if you have a situation like a real life situation, your reference angle is always the angle of significance for whatever it is that you're talking about. So if you get your reference angle as the wrong angle, then your information is going to be backwards. So this is why it's really important to always know your reference angle. It's key to note that it is never the right angle. The reference angle is never your right angle. It's always one of the other two angles. So you can label your reference angle as A or something else depending on the situation, but it is always going to be part of your question. They have to give you that information, or that has to be what you're looking for, so you know what it is that you're talking about. Then we're going to label our other two sides. So your opposite is always across. It's opposite the reference angle. So that's how you always find your opposite side, and I label it OPP. I've had students who struggled with this, and I've told them that the OPP, you want to stay away from them, so they're the farthest side. It is the opposite away from you. Maybe not necessarily the best strategy for teaching teenagers in high schools, but it's something that helped them remember. Then sine, this ratio that we've been talking about, is equal to the sine of A, so the sine of our reference angle, is equal to the length of the opposite side divided by the length of the hypotenuse side. So we're just saying that this is a ratio. Always, no matter how big or how small your triangle is, this ratio in relation to this size of this angle is always going to be the same, because that's what we've been talking about with similar triangles, right? It doesn't matter if your triangle is big or little, this ratio is always going to be the same. So basically your sine of A is equal to the opposite over hypotenuse, which I shorten to sine A equals OPP over HYP. That's how I write it down. I always write it down like this. I always write out this many letters just to keep myself organized. We'll talk a little bit later about something else you can do if that's helpful. So some people write just S equals O over H and say saw. That's how they remember it, is that sine is opposite over hypotenuse. This is the saw. Okay, so let's look to see how we actually find a sine length with this information. And this is on page 4 of your IL booklet. So solve X for X. We have a triangle. P is our reference angle. 17 degrees. We are looking for x. Our hypotenuse is 13.2 centimeters. So I always take my triangle, whether or not it's written, I might draw a sketch. It does not have to be a perfect sketch, doesn't have to be exact. I label it. The labeling is the most important. So I look at my reference angle and I find my opposite side and I label it. So the x is the opposite side. The side across from the right angle triangle is the hypotenuse side. So I know that sine of p is equal to opposite over hypotenuse. So then I'm going to substitute in all the information that I know. So sine, so my angle is 17 degrees. So sine 17 degrees is equal to x over 13.2. So what I'm saying is that the ratio, if I have a triangle that has an angle of 17 degrees, it has this same ratio. I know one side of that ratio, one part of it, and I'm using that information to figure out the other part. So then in order to isolate for x, I'm going to multiply both sides by 13.2, just like we algebra in general, which means that 13.2 cancel off on the side with the x. And x is equal to 13.2 times sine 17. Now, sine 17 is one thing. It is not sine and 17. Sine 17, sine only makes sense in context to a number and to a ratio. So you have to have that sine in the 17. So you're on your calculator button for sine is SIN. Some people say sin because the short form is sin. I still say sine even if I'm talking about, even if I have it written in the short form. So your scientific calculator has to have this button somewhere. If you can't find it, let me know and we will find it together. Yes. So when you press sine 17, so if you do 13.2 times and you press sine 17, you're going to get 0.29237, and that is equal to x. So x is equal to 3.9 centimeters once you multiply those two numbers together. If you're going to write down, after you do sine 17, you're going to find that it's a really long decimal. If you're going to write it down, then I would strongly suggest you write 5 decimal places in order for it to get accurate. If you can, it's best to leave it just in your calculator as sine 17 and let it hold all that information. But if you want to write it down and round it off, then do it to 5 decimal places, please. That'll set you up for the most success. Also, your calculator must be in degrees. This is super important. It must say on the little screen DEG. If it says RAD or GRAD, you're in different units. So we need it to be in degrees. We're talking about 17 degrees. We're talking about a system of measurement that is talking about in degrees. So your calculator must say degrees. If it doesn't and you're not sure how to change it, let me know and I'll help you find the button for you to change it. I'm pretty sure it's like it says DRG and you just press it through until you get to where it says degrees. But it's super important for all of this trig stuff. Your calculator has to be in degrees. I'm going to keep saying it. Yes, so here I remind myself, if it says rad or grad, press the DRG button until it says degrees, DEG. All right, so how to find the side length. We're going to do another example. So this time we're going to solve for y. So we have a triangle, angle T is 64 degrees. Then we have one side that is 58.1 centimeters and one side that is y. So we see the side opposite the reference angle T is the opposite, is 58.1. The hypotenuse is the side that is across from the right angle. So here, sine t is equal to opposite over hypotenuse. I start my questions like this to keep everything organized. And I fill in what I know. So sine 64 degrees is equal to 58.1 divided by y. So I'm substituting in my values that I know and I don't know into my formula. So I can then solve for my unknown. This time my unknown is in the denominator. So it means that I need to do a little extra step. We need our denominator to be, our variable to be in the top. So we're going to multiply both sides by y in order to cancel it off from being on the bottom on the one side. And then we're going to divide both sides So then we're left with y sine 64 equals 58.1. And we're going to divide both sides by sine 64. Remember, sine 64 is one thing. So we cancel that off. And we get y is equal to 58.1 divided by sine 64. So then we do that on our calculator and we get y is equal to 64.4 centimeters. So this hypotenuse length is 64.4 centimeters. Remember, your hypotenuse will always be your longest side. So for some reason, once you solve this, if your hypotenuse is not the longest side, you know you've made a mistake somewhere. Very possibly your calculator is not in degrees, or you didn't press the sign button. So these are key things that you need to always remember. All right, so now you can do the support questions on page 1 through 4. And then we're going to solve for the unknown angles in our next lesson. So we're going to come back to these same support questions, but we're going to do the angle ones later. All right, now we're going to look at the cosine ratio. So this is on page 7 of your IEL booklet. So we're going back to the same place, the cosine ratio. We need to know that the hypotenuse is always the longest side, which is across from the right angle. This is still true. So what we had before, still true. Still important. The reference angle is the important angle in the situation, and it's never the right angle. Still true. Still what we need to know. Our reference angle is still important. Now we have a new name of our side. So our adjacent is always next, or adjacent means beside, to the reference angle. So it is the side that is always beside the reference angle. And I label the adjacent as ADJ. That is the name that I give it. The first 3 letters of adjacent. So our cosine ratio, so we say cosine of A is equal to the length of the side adjacent angle A divided by the length of the hypotenuse side. So this, no matter how big our triangle is, if it's really little, if it's really big, if our angle is the same, the ratio of the sides are going to be equal to each other. Specifically looking at the cosine, if we're comparing the adjacent side to the hypotenuse side. So you need to remember that cos A is equal to adjacent over hypotenuse. Or as I write it down to keep myself organized, I write cos A equals ADJ over HYP. I say adjacent over hypotenuse, but I just write the first 3 letters of both words. Then the other commonly way to remember this is to say CA, C for cosine, adjacent, hypotenuse, so CAH. So just like we had SOH, and CA, CAH. These are ways that other people remember these ratios. All right, so then how do we actually find a side length? So you have some examples on page 8 in your IEL booklet. We're going to, so we have a triangle that has a reference angle Q, which is 53 degrees. Then we have a side 72.8 millimeters and the side K. We need to solve for K. So K is our adjacent side. That is our side that is beside our reference angle. That is not the hypotenuse. And the hypotenuse is across from the right angle. You don't have to label the adjacent first and then the hypotenuse. You can label them either way. I strongly encourage you to label your sides though. This helps to set you up for success. You could label the hypotenuse first and then label the adjacent. Just make sure you're labeling. It's really important. You don't, of course, never have to. You never have to do anything. But this is really going to set you up for success to help keep your information organized. So then we have cos Q is equal to adjacent over hypotenuse. So fill in what we know. Cos 53 degrees is equal to K divided by 72.8. Sorry. So then in order to isolate for K, we're going to multiply both sides by 72.8 and they cancel each other off. So we're left with 72.8 cos times cos of 53 is equal to K. So we're going to use our calculator button for cosine, which is cos, C-O-S is cos. And so we're going to do that. We're going to, so we press, so 72.8 times, and then you press cos 53 and you'll get 0.6018. This time I run it off to 4 decimal places. I still would suggest doing it to 5, but you can do it to 4 too. So then K is equal to 43.8 millimeters. Still, your calculator must be in degrees. This is always true, but I'm going to say it every time to just drive it home. And continuing for the first little while to say that if it's not in degrees, if it says rad or grad, that you press the D or G button to get to degrees. Okay, so another example to solve for the side length. So we're going to solve for Z. So in our triangle here, we have, these are right angle triangles, the reference angle of W, which is 40 degrees. Then one side is 29.4 centimeters and one side is Z. So our adjacent side this time is 29.4 centimeters and our hypotenuse side is Z. So cos of W is equal to adjacent side ADJ divided by hypotenuse. Fill in what we know. So cos 40 degrees is equal to 29.4 divided by Z. Now to isolate for Z, we're going to multiply both sides by Z and cancel it off on the one side where it's in the denominator. And then we have Z times cos 40 is equal to 29.4 and divide both sides by cos 40. Then that's going to cancel it off, divide both sides. So Z is equal to 29.4 cos divided by cos 40, which is equal to 38.4 centimeters. That's how you find side lengths using cos. So you can now do the support questions on page 9, questions 8 through 11. Again, we will come back to solve for the unknown angles in our next lesson. And then finally, we're going to look at tangent ratios. So this is on page 12 in your IL booklet. Again, we are going back to the same basic principles. It's the same once you get practicing, you won't even have to think about them as separately anymore. They are all the same. So our reference angle is the important angle in the situation. But this time we're looking at our opposite, which is always across from our reference angle, and our adjacent, which is always next to the reference angle. So with tangent, we're not looking at the hypotenuse. We're looking at just the opposite and the adjacent. We're looking at those two ratios. So tangent tan A is equal to the length of side opposite angle A divided by the length of the side adjacent angle A. So tan A is equal to opposite over adjacent. And I write this in my short form as tan A is equal to OPP over ADJ, opposite over adjacent. And this people shorten down to TOA, TOA, tan, opposite, adjacent. That makes it, that's how people, it's another way that people remember it, is calling it TOA. So they have SA, KA, and TOA. That helps them remember. So let's look on an example. This is like the examples on page 13. So we're solving for the side length. That's what we're doing today. We have a triangle with reference angle of F, a side G, and a side 17.3 millimeters. Sorry, I forgot to say that the reference angle is 74 degrees. So the side opposite, which is G, is the opposite. The side adjacent is 17.3. That's your adjacent. So tan F is equal to opposite divided by adjacent. So tan of 74 is equal to G divided by 17.3. So isolating for G, we're going to multiply both sides by 17.3. So they cancel off. And we're left with 17.3 times tan 74 is equal to G. Using our calculator button, which is tangent, TAN is our tan or tangent button on your calculator. Again, you should have all of these buttons. They're generally lined up in a row on their own. 1, 2, 3, like sine, cosine, tan is how they show up on your calculator. So then 17.3 times tan 74, which is equal to 3.4874, is equal to G. So G is equal to 60.3 millimeters, which if we can see on our triangle, that is a bigger side, so that makes sense. Again, always your calculator must be in degrees. Put it in degrees by pressing the DRG button. Generally, they usually are in degrees, but if something's happened, a button's got pressed, it might not be in degrees. So another example, solve for D. We have a triangle with our reference angle J is equal to 20 degrees. We have a side length D and a side length 6 centimeters. So our 6 centimeters is our opposite side. Our D is our adjacent side. So tan J is equal to opposite over adjacent. So tan 20 is equal to 6 over D. So multiply D, both sides by D in order to bring it up into the numerator. They cancel off on the one side. So you end up with D times tan 20 is equal to 6. Divide both sides by tan 20 in order to isolate for D. D is therefore 6 divided by tan 20. So D is equal to 16.5 centimeters. And now you can do the support questions on page 14, question 15 through 18, and we'll come back to solve for the unknown angles in our next lesson. So the trickiest part about all of this, one of the trickier parts, because everyone's going to find different things tricky, but a tricky part about this is knowing which ratio do you actually use. Do you use sine? Do you use cosine? Do you tan? How do you know? I've taught them all together. How do you know which one to use? So you decide the ratio based on the information in the question. So first, confirm that it's a right angle triangle. That in order to use a sine, cosine, and tan, in order to use your primary trigonometry ratios, you have to have a right angle triangle. So that's step one. Figure out that you have a right angle triangle. Yes, in this question we do. Step two, label the sides of your triangle. This is going to give you the most information, so that's why I encourage you to do it. So you need to know where your reference angle is. So you need to figure that out. And here in my example, my reference angle is B, which is 36 degrees. And then I have opposite. So I'm going to label my opposite, which is 48. And I have adjacent. So my adjacent is my N. I label my opposite and my adjacent, and that's really useful. I can still label my hypotenuse. I don't have any information about it. I don't have either a letter to help me figure out that that's what I'm finding or a number to give me information, but I can still know that that's my hypotenuse. That might be useful. Or I can leave it off if it's not useful. That's fine too. So then step 3 is identify which information you know and what you are solving for. So we know the adjacent is N, so that's what we're solving for. The hypotenuse is 48 and the reference angle is 36 degrees. So those are the pieces of information that we have, and N being what we're looking for, but we know which side that is because we have a variable for it. So that's why we can ignore the hypotenuse. It's not helpful for this question. So that's why you don't have to write it down if it just ends up confusing you. So then we now choose our ratio. So we think about our 3 ratios. We have sine B, because our reference angle is B. So we have opposite over hypotenuse, adjacent over hypotenuse. Sorry, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. Well, we are looking for our opposite, we have our opposite and we're looking for adjacent. So that means these ratios that have hypotenuse in it are not useful for us. We don't have any information about that. So that doesn't help us. So that means that we're going to use tan because opposite is what we know and adjacent is what we're trying to find. And so we're going to use our tan ratio in order to solve for this unknown N. And then we can solve it. So those steps, this is a really good place to come back to and replay this part over, or to screenshot this part that has these 4 steps. Even though I've had animations and the sort of information has changed, this hopefully will help you remember how you're able to figure out which of the three ratios to use. All right, so we have a few minutes to do some practice questions. So let's dive in and do some practice questions. So in each triangle, name the side. This is number 1. So there's 3 different ways that we can label our sides, which I think your book talks a little about. I accept all 3 different ways of how you might want to label them, as long as if it's correct, if it's one of the 3 ways that are correct, then I'm fine with any of the 3 ways. So for part A, we have adjacent. So we're looking at the side, name the side that is adjacent to angle R. So here, if we look on our triangle, oh, I need my pen. Okay, so here is my reference angle, and I'm looking for the side that is adjacent. So if you wanted to label it on the triangle and actually write the word adjacent in the right place on the triangle, that is totally fine. If you wanted to name it and you looked at the side and you said, well, I start at P and I go to R, so that means that this side is named PR, with a little line above it, technically, in order to say that it's a side length. That is also totally fine. That's another way we could label it. If you wanted to look and say, well, it is the side across from angle Q, and I'm going to label it little q, because that's another way that we label line, that is fine too. So these 3 ways are all totally fine. I would accept line segment PR. I would accept side Q, little q, not capital, little q. The capitals matter. So it's capital P, capital R. If you're using the vertices, if you're talking about the side, then it's little q. Or if you label it on your triangle and label adjacent in the right place, that is fine too. Okay, so part B, the hypotenuse. The hypotenuse is across from the right angle. So you could label the hypotenuse just on the triangle. Great. You could also call it's going from J to K. It's that side. So you could call it line segment JK. Or you could call it little h because it is across from H, which is our angle, which is our right angle. That would be fine too. And then part C, the side opposite at angle M. So the side opposite angle M is over here. So you could label it OPP or opposite. You could call it line segment LN, or you could call it little m for being a line that is across from angle M. All of these are correct, and I would accept each of them. One isn't better than the other. They're all technically correct. All right, so then let's look at a word problem, real life situation. A ladder is resting against a tree. The foot of the ladder is 2 meters from the base of the tree. The ladder forms an 48-degree angle with the ground. How far up the tree does the ladder reach? To the nearest 1/10 of a meter. So this is 1 decimal point is what a 1/10 of a meter is. So with these questions, if you are not given a triangle, which in this situation we are not, then draw yourself a image. As every teacher who draws, who is not an artist, will say, I'm not very good at drawing. You don't have to be good at drawing. It doesn't matter. So here's my tree and the foot. So then I have a ladder leaning up against my tree. With buildings and trees, we assume that they are at a right angle to the ground. Even though my drawing does not make it look like a right angle, we assume that that's how things grow. They grow straight up. Oh, my drawing is just getting worse and worse. Okay. So the ladder forms a 48-degree angle with the ground. So that is this angle right here. My ladder is there. My angle is here. Again, obviously not beautiful, but I'm labeling it. That's the important part. The foot of the ladder is 2 meters from the base of the tree. So this distance here is 2 meters. This is why drawing a picture helps you figure out what it is that you're doing, even if your picture is awful. How far up the tree does the ladder reach to the nearest tenth of the meter? So that's saying how far is it up here? What is this distance here? So I'm going to call it T for tree. That's what the question is that we're looking for. So if it's confusing on your picture with your ground and your tree, you can also just draw it without the ground and the tree. You can just draw yourself a triangle and then label it properly, and that's fine too. So we have our reference angle here. Let's call it A. We have our opposite, which is across, is our P, our OPP, which is our tree. And we have our distance from the tree to the base of the ladder is our adjacent. So that's the other piece of information we know. So we have a right angle triangle. We've labeled our sides. Now we know our adjacent, our reference angle, and we're looking for our opposite. So we think opposite adjacent is tan. So tan of A is equal to opposite over adjacent. This is why I write it out over and over again so that it's easy for me to remember, so that I fill in what I know. Tan of 48 degrees is equal to T over 2. So that means that I multiply both sides by 2 to cancel off the 2. So 2 times tan of 48 degrees is equal to T. So now we're going to use our calculator. As you can see on my Desmos calculator, here it says degrees. It's a little bit different than if you're using a physical calculator, but it says degrees here, DEG. So if I changed it, then it would say RAD. That's not what I want. I want to say DEG. And then here are my sine, cosine, and tan. So I'm going to do 2 times, sorry, my computer hates me. And then I say tan of 48. You need to figure out how your calculator works. As you can see, my calculator hates me. So sometimes you press tan first, sometimes you press the number first. You have to figure that out for your own calculator. Let me know if you need help with that. So we get 2.22. So T is equal to 2.22 is equal to T. It's set to the nearest tenth of a meter, so we only want 2.2. So therefore, the ladder reaches 2.2 meters up the tree. A sentence helps you know that you've answered the actual question. And there we go. We've used it in a real life situation. All right. Quick practice question number 3, where it just says to calculate. So this sort of question, you are just literally doing using calculator. So you're going to do sine of 29 is equal to 0.48481. Cos on your calculator, you press cos and you put in your angle. 84 is equal to 0.10453. 453. And tan on your calculator, tan 55. Hopefully your calculator doesn't hate you as much as mine hates me. 1.42815. 1.42815. And that's all you need to do when you're just calculating the ratios. You're just finding what the ratios are. All right, we don't have time to do these last 2 problems. We have a minute to consolidate. So just a reminder, your trigonometric ratios, this is the first part of lesson 11. So we looked at sine, cosine, and tangent. We know that labeling the right angle triangle is essential. This is super, super important. SOHCAHTOA is one way to remember it. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. TOA, tan is opposite over adjacent. That's one way of remembering them. And to solve for an unknown side is what we learned how to do today. And your calculator must be in degrees. Super, super important. So hopefully you can identify the opposite, adjacent, and hypotenuse sides. and you can solve for an unknown side using our trig ratios. Again, we will complete this lesson tomorrow in our next class. If you have any questions, please reach out and contact me in all the usual ways. I'm here to help you however I can. Thank you so much for joining me today. Have a great day. Miigwech.